Today I want to do a video about finding the slope of a line given a graph, a table, or an equation. Our first examples here are graphs. I have 3 examples like that. And we're going to find the slope of each line that's graphed. I graphed these lines, so you're going to notice little dots. See here where I put those dots and I tried to draw a straight line. But when you have a computer generated line, you're not going to see those dots, but you're going to want to look for places where the line intersects in the corners perfectly. You're going to want to look for those. And you want to pick 2 of them. It doesn't matter which 2 you choose, but you want to pick 2 of them. So I'm going to pick this one. Oh, that pen won't write. I'm going to pick this one and this one. It really does not matter which 2 you pick. When you do this, though, you're going to find 2 numbers. You're going to find the number for the rise and the number for the run. Okay, so let me write something up here. So you're going to find the rise and you're going to find the run. That's what slope is described as. It's the steepness of your line. And the steepness is measured in the rise and the run. And I like to think of these as literal things. Rise. When you rise out of bed in the morning, you get up. So I start from this lowest point and I count how far it takes me to rise to the point that I've selected. So I'm going to start here. I rise 1, 2, 3, 4 units. So my rise here is 4. And then for my run, from where I stopped counting the rise, I'm going to count how far it takes me to run to this point. So it takes me 1, 2 positive units to run to that point. So this line here, if you notice, it rises to the right. It has a slope of, and you'll reduce these, 4 over 2 reduces to 2. So the slope of this line, represented usually by the letter M, the slope is 2. There's really no work that you can show for this, except you could draw the line and you could show 2 units here. Oh, sorry, that was 4. 4 units here and 2 units here. Now I want to point out something. I did not select this line, this point. But I could have, and if I would have, watch what happens. Rise of 1, 2 over 1. So there it would have been reduced already, up 2 over 1. To get to this next point, you're going to go up 2 over 1. Consistently up 2 over 1. That's the slope of this line, up 2 over 1. So the slope of line 1 is 2, positive 2. Let's look at number 2. Now, number 2 looks very different from number 1. This line intersects perfectly in the corner of all of these points. There's one way you can think about this. Let me show you. If you count your rise, if I chose this point and this point, then my slope would be rise over run. And if you rise 1, to get to that point that I've selected from the lowest point that I selected, how far do I run left or right to get to that point? Well, I don't. Now, that should look strange to you. 1 over 0. Well, this would be not possible, 1 over 0. So the slope here would be undefined. Most students just remember that if you have a vertical line, the slope is undefined. That means that there's no specific answer like 2 that you would get, because I could have risen 5 and nowhere left or right. I could have risen 10 and nowhere left or right. So my slope is undefined here. Let's look at number 3. That's definitely not a vertical line. And I'm going to select this point, which is that y-intercept where that graph crosses the y-axis. So I'm going to select this point and this point. And I'm going to find the slope. Slope is rise over run. How far do I rise to get to that point? I rise 1 unit. How far do I run? I run 1, 2, 3, 4 in a negative direction. And I'm going to put -4 here, but I'm going to show you the best way to write that. The slope of this line is -1/4. Really and truly, the negative should not be with the numerator or the denominator, but it does show me that my slope of this line is a negative slope, and it rises to the left. So -1/4 is the slope of this line. I'll circle this answer as well. Maybe. Okay, now let's do number 4. Okay, so that looks interesting. I'm going to select 2 points, and notice you can see all kinds of points. I'm going to select this one and this one. This one and this one. To find my slope, slope is rise over run. Okay, so from this point to this point, how far do I rise? Well, I rise 0. How far do I run to go from here to here? I run 1, 2. I run 2 points. Can you find an answer to 0 divided by 2? Yes, that answer is 0. So the slope of this line, which is a horizontal line, is 0. All horizontal lines have a slope of 0. All vertical lines have a slope that's undefined. Now let's go on to if you have a table. These ordered pairs definitely belong to a line. So I know that these belong on a line. Now there's a couple ways you could do this. You could graph these ordered pairs and count the slope, or you could use the formula for slope. The formula for slope is slope equals y sub 2 minus y sub 1, because that's your rise. When you're talking about rise, you're talking about on the x-axis. So rise goes on top over x sub 2 minus x sub 1. Now what in the world does that mean? What do these subscripts mean? Well, let's talk about that. I'm going to select 2 points up here, and it doesn't matter which 2. They could be consecutive. They don't have to be consecutive. I think I'll select the first 2. I'm going to choose -1, 0, and I'm going to choose 0, 1. Okay, so here's how you need to think about it. This is the first x you see. This is the first y you see. This is the second x you see. This is the second y you see. So then if you just notice, now we can fill into the formula. The slope is y sub 2 minus y sub 1. So 1 minus 0 over x sub 2 minus x sub 1. 0 minus -1. If you go ahead and think of in your mind as 0 plus +1, that's perfectly fine. And then I have 1 on top. 1 minus 0 is 1. I have 1 on the bottom. 0 plus 1 is 1. And then that reduces to the slope for number 5 is +1. So without even graphing, I know that this line rises to the right. It would look more like number 1 up here. Okay, number 6, I'm going to select, I'll just use the first 2 again. I'm going to use -3, 0, and I'm going to use -3, 1. And I'm going to use that same formula, y sub 2 minus y sub 1, 1 minus 0, over x sub 2 minus x sub 1. Okay, 1 minus 0 is 1. 3 minus -3 minus -3 is the same thing as -3 plus +3, and that is 0. And can I divide 1 by 0? No, I cannot. So then this is undefined. I'm going to show you something that you could have not shown any work. You could have just said that this is the reason why you chose undefined. Our poor little dog is taking a nap and barking in her sleep. Okay, so anyway, undefined, I would have known that if I would have just noticed that all the x values in my table are the same. That means that I have a vertical line, because on this vertical line, all my x values are -3. So when you have all the x values the same, then your slope is always going to be undefined. Okay, one more table. Maybe you'll notice something as I select the first two ordered pairs. -1, 6, and 0, 6. Let me check something. Yes. Okay, so my slope is going to be 6 minus 6 in the numerator over 0 minus -1 in the denominator. 6 minus 6 is 0. 0 plus 1 is 1. 0 minus -1, 0 plus 1, and 0 divided by 1 is 0. So the slope of this line is 0. I know that's a horizontal line. All horizontal lines have a slope of 0. I should have also known this is a horizontal line by the fact that all of these numbers are the same. If you look up here, 1, 2, 3, 4, every y-coordinate on this line is 4. So that's how you would have known that those are the same. Okay, so there is by graph, by table, and now from an equation. And we're also going to find the y-intercept. I'm going to look at these three and talk about the easiest one first. The easiest one is number 9. Number 9 is in the form y equals mx plus b. This is called slope-intercept form. And when it's written this way, it is so easy to find the slope and to find the y-intercept, which is where the line would actually intersect the y-axis. So if you notice, y equals mx plus b. So here m, which stands for slope, the slope of this line is 4. The y-intercept of this line is 10. So that one's easy and done if you remember slope-intercept form. Slope is 4, y-intercept is 10. Now, of the other two that I have left, which one would probably be the easiest? Well, I think number 10. But if you look at number 10, what's missing from this equation that this has? Think about it for a second. What's missing from here that this has? Well, hopefully you notice that there's not an x here. X is missing, and since it's missing, that means it's 0x. So now I can quickly say that the slope y equals m, so the slope is 0. If x is missing, your slope is 0, plus b. Well, notice this isn't a plus sign, so my b value is -8. So slope is 0, y-intercept is -8. How do I do number 8? Is there a way I can make this look like these? Yes, I can. I want to get y alone, or isolate y. How do I do that? Well, I get rid of this 8x first by subtracting 8x. So I would have positive 3y equals, and I put my x first, -8x plus 18. Now, is my y isolated or all alone? No. So how do I do that? I divide by 3. I divide every single term by 3. And I will have y equals, that won't divide, so I'd have -8/3 x. 18 divided by 3 is 6. And so then I have a 6 there. And now, using y equals mx plus b, I can say the slope, it's beside the x, is -8/3. And the y-intercept, the b value, is 6. So that's how you find the slope given a graph, given a table, or given an equation, and also how you find the y-intercept. I hope that helps.